Good day and welcome to this session for Physical Sciences. I'm Mr. Marnus Kleinhans, Subject Advisor for Physical Sciences at the Mateo District. And this is our final time that we have time to do our prep and to spend time with you and talk about tips and tricks, things that you can expect in the papers. So welcome for that. And let's dive into this beautiful subject. And you know we are writing paper 2 on Monday, which is chemistry, and yeah, paper 1 is done. And let us see how we can look at the work. So the first thing I want to say is that every learner in the Free State received a terms and definition book, like the one I'm also showing for the learners that's not at the radio but on the other platforms. I want to request you, if you have that book close by, that you will then quickly fetch that book. If not, have a pen and paper close by, whereby you can dot down some of the pages that I'm going to refer to in these books, because you have all received these books and I know you've been working very hard from them. So please, while I talk in general, grab those things, have it on hand, because you will get a lot of information. It will also make the radio broadcast more visible for you if you can look at the pages that I will be referring to. So a broad overview of my presentation today and the talk that we are going to have is I'm going to look first of all into general tips. Now these tips is generic and most probably you've heard it before also from other subjects, but let's just quickly go over them again. Then I'm going to look at chemistry specific tips and tricks that might help you, and I would like to look at a few of the basics per question that you can expect in the paper for Monday. So that is a broad overview of what we would like to achieve. All right, some general tips. If you look at general tips, you have to plan your study daily. And I can tell you that, you know, if you plan your day, if you think about maybe tomorrow, I would strongly advise you to try and put away 10 hours at least, which you might plan to put into smaller chunks. The days are over of studying 3 hours and go and write the exam. The work is just too demanding. So plan your study. If you haven't planned already every day, start today. A good indication, and it differs from person to person, will be to use maybe a 50-minute study block, and then from there you take short breaks. And I don't expect you to take a 10-minute break for lunch, but there you can have a longer break. But break these topics also up into smaller, manageable sections. You know that the topics that we have, that we're going to look at, is organic chemistry, reaction rate, equilibrium, acids and bases, your galvanic cells, your electrolytic cells. So break your topics up into manageable sections. And some advice, I would like you to start maybe with the easier topics, your organic chemistry, and I strongly believe redox reactions is also quite an easier topic. And first work through them. And then also while you are working through your topics, look at the marking guidelines. This is very, very important. In the marking guidelines, you will pick up what you need to write down in order to get your marks, and the wording that they are looking for to get the marks. So, and also when you're doing calculations, exactly where is the mark allocated to get marks when doing a calculation. Right, so also remember that when you work through questions in these terms and definition books that you have received, which have got numerous old question papers in there already for you, allocated in specific topics, that when you look there, the first couple of questions is normally your level 1 to 3 questions. And depending on what you are aiming for in the exam, you might decide to focus more on level 1 to 3 questions. If I'm a learner that just want to pass on Monday, then I would strongly suggest that you don't spend too much time on level 4 questions. Level 1 to 3 is normally in a question. You will see that it will be allocated earlier in a question. All right. Then my next step for you would be study your definitions. Definitions, more than 10% of your paper. So by knowing your definitions, and if I feel that there's too many definitions, then I would look at old papers, which definitions repeat. And I will make sure that those ones that they repeat, that at least I know them also. But as I go through questions, put time aside to study your definitions. And don't wait till Sunday evening to start to study definitions. Already today, study your definitions. Repeat them tomorrow. Repeat them the next day. And also that morning when you wake up, before you go and write, you try and put an hour aside. And then that hour goes into your definitions again. So definitions, 10% of the paper. And that will now help you so that the other topics can push your marks up so that you can pass or get higher levels and do well. All right. Make sure that you can work undisturbed. I know a lot of you are incubated. I know a lot of you are camping. You are most probably studying over this weekend in a class. So sometimes you know how to work with in a group, and it works very well. When I visit schools, I see this all the time. I see learners with a study buddy where they motivate one another. Studying with your teacher is great because then you can ask questions and you don't waste a lot of time trying to get to an answer. And make use of this so that you can plan your studies, so that you can manage your time, and that you can get the most of the couple of hours that you have left till you write paper 2. So that is general tips. I hope by now you have reached out, find your books that we've given you, and that when we go into more detail that you will be able to look at that. All right. If you look at study methods, this is very important. Don't just read through notes or a textbook. You need to be active. Make summaries, make checklists, make mind maps. It's very nice to make some mind maps. Highlight important facts by underlining or having a highlighter that you work through it. And the work that you need to memorize, write out those definitions. Memorize them. And like I indicated already before, so yeah, it's nice sometimes when you have a study buddy that you say a definition, now you're challenging, you give him a different definition, he has to give it back, and now you play a game like that. That is very nice. The book 2 that you will know that I spoke about earlier, the book 2, which is your summaries, terms and definitions and questions that you have received for chemistry from the Department of Education, that book, and this is very, very important, summarizes all content very well. Yo, guys, I can't tell you how nice summaries you're going to find in there. And I would strongly advise you to go through those summaries before you start to work through question papers, because the question papers will address those summaries. Things that I've highlighted or underlined again. So yes, those books and summaries is your secret to the knowledge that you have to have when you write on Monday. You know, you can't write the answer if you don't know the answer. Especially in chemistry, there's a lot less understanding on its own. It's always understanding coming from the content and the concepts that you need to know. So using these summaries in book 2 I would strongly advise you to look at them and work through them numerous times until they become your own. Then when you look at the questions, yes, then you will see that how it is applied now in question form. So please make use of those summaries to get your content up to date. All right. Now let us start. That was all of those that I've spoken about up till now was general tips. Now I want to start to get to a little bit more chemistry specific tips. So from here on out, I'm going to look at specifically our subject. Now the first thing I want to emphasize is you are going to receive a data sheet. Now, whenever you study, whenever you work through question papers, have that data sheet next to you. Make sure that you have your data sheet. What do we find in the data sheet? In our data sheet, you're going to find constants that you're going to use when answering questions, especially maybe calculations. So if a question talks about an electron, then you will see that there you will find the charge of the electron, the mass of the electron, and so forth. If it speaks about a chemical compound, then let's say sodium chloride, then in your data sheet you're going to find a periodic table. There will be a periodic table. There you will find all the data that you will need to be able to calculate the molecular mass of sodium chloride, for example. So your data sheet, your periodic table with constants and things like that in there, very, very important that you know where to find the information. So having a data sheet, a complete data sheet next to you, very, very important. If your teacher is there with you in class, ask him. If he can't supply you, you might find it in your textbooks or you will find it in some other books as well. Right, then you're going to find also a table with reactions. Now, the reactions I'm referring to is there's a nice table in there for redox reactions, reduction oxidation reactions. And in the Free State, we most of the time uses table 4B. Now, you will see in the data sheet, there's also a table 4A. Now, here I normally advise learners, when you open your data sheet, draw a line through table 4A if you are used to only working with table 4B. You know, sometimes during the exam, you get in a rush because you felt you have spent too much time on a certain question and you don't want to fall into the situation where you are by mistake using table 4A and you should be using table 4B. I know that normally we work with table 4B in the Free State, so then if you see table 4A, draw a line through it so that you don't just rushing through it, use the wrong table for that information. On table 4B, you're going to find a whole list of chemical reactions that we use when we get to those questions. And you don't want to use the wrong one. Then, of course, also on my data sheet, we find formulas that we will need for calculations. So whenever you need to calculate, make sure that you look for that you know where to find your formulas. Like if you want to calculate concentration, you need to know where you will find that formula. If I want to calculate the number of moles, I need to know where to find that. Also on data sheets, we normally group formulae together per topic. So that will also help you. Then if you work enough with your data sheet that you know it and know when I'm busy with a certain topic, let's say I'm busy with chemical equilibrium, then I will know where to find my formulas related to that. Or when I'm working with reaction rate, where will I find the formulas that I can nicely use with reaction rate? So be sure to understand and know what you have in your data sheets. That is really, really important. All right, more tips that I can talk about is, remember, when you have done a previous sub-question, let's say I'm now busy with question 4 and I have answered a certain question, maybe even a calculation, and there's another question, your previous answer can, a lot of the time, guide you to the next question. And also, if you've got one calculation followed by another calculation, then the first calculation normally will guide you. You will need that answer when answering the next sub-question. So also, it's important then that you don't leave a question open, especially when it comes to calculations. So that, because we use a way of marking, which we call positive marking, that should the first sub-question's calculation be wrong, and you move on to the second calculation, and you use that wrong values, we still accept it. So it's positive marking. So remember this guidance from a sub-question to the next one. All right. Then, when you study, don't focus too much on the answer. Rather, especially with calculations. So rather focus on identifying the correct formulas and things like that. And I will give you tips now also specifically for calculations when it gets down to doing a calculation, so that you can improve the way that you answer questions when it's relating to calculations. Right, so let us then now talk about calculations. What is it that we focus? I just said now, don't focus too much on the answer, and I'll explain why I'm saying that. The first thing that I will focus on is, what is the question? When reading my question, calculate the reaction rate, then I will highlight that the question is that I need to answer reaction rate. That is what should be my final answer. And sometimes I need to calculate something else that I'm needing in order to calculate the reaction rate. So find what is the question. The next thing that I would look at, and there I use my highlighter a lot of the time, is that I'm looking for what information is given to me directly. They might say to you how the number of moles have changed, or what was the time that it took for a certain reaction to take place. I'm looking for values, that is data that is given to me directly, and I highlight them. Then sometimes information is given to you indirectly. Like, am I working with products? Am I working with reactants? Am I calculating something with electron? Like I indicated earlier, then I might have the mass of electron. They are not going to give you, for example, the molar mass of an element or the molecular mass of a compound. They just need to say the word, like hydrochloric acid. Then I know I can calculate the molecular mass. So info is given to me indirectly in the periodic table, and I need to look for those information. After I've done this first three steps, what is the question? What is given directly? What can I calculate, or what can I find indirectly? What is given to me, which is on the data sheet indirectly? Then I can find the formula. And using a wrong formula, already I'm penalized with a 0. But so I use the first three steps to find the correct formula. And now I will substitute the data that was given directly, or the data that I calculated from my periodic table, or the data that was given indirectly that I could find on my periodic table. And I substitute that. Now let's say a calculation is 5 marks. Then up to here, it will be 4 marks. So you can see that 80% of the marks is not given to the answer. 80% of the marks was organizing your data, finding the correct formula, substituting that correct data into the formula. So that's 4 out of the 5 marks. The answer plus unit, that will be the 5th mark if a calculation is 5 marks. So the answer is only 20% of the total marks that you can be receiving. So normally we will find that identifying the formula, substituting, will be 60 to 80% of the marks obtained for a calculation type question. And then of course the rest will be going to the answer and its unit. So that's why I'm saying the answer is not the major thing to focus on, but going through this process so that you can get the 60 to 80% for a calculation. And if you can get 60 to 80% of a calculation every time a calculation was asked, then you are passing this paper. You are doing well in this paper. So that for me is very important, that you have a strategy when it comes to calculations. What is the question? Order the data given to you directly, find other data from your data sheet, and then find the correct formula from your data sheet. Then you substitute. That will be the process that you need to focus on. Lastly, you go to your answer and the unit that's needed for that answer. All right. Now, that was chemistry-specific tips and tricks. I hope this will help you in your approach to questions. So let us now look at the question paper itself and the different topics that you're going to get in that question paper. All right. So if we look at a basic question paper, normally question 1, or on Monday question 1, will be multiple choice questions. All right. So you're going to have 10 multiple choice questions, and you need to manage your time carefully also here, because here at the multiple choices, we don't want to spend too much time with it. So, because you want more time for the other questions, and at the end you can always come back. But at the same time, you want to answer the multiple choice. So 20 to 30 minutes for the 10 multiple choice questions, nothing more. But work as accurately and as fast as possible. So my first tip here is underline keywords. Underline keywords. If I look at the question, and when I'm underlining, also it goes there that pays attention to words that are in capital letters. So I'm going to underline keywords. I'm going to look out for capital letters. I'm going to look out for words that's emphasized, highlighted, boldly printed. Then I know I'm there. Now let me make an example here. If I'm looking at the question where they are saying which one of the following compounds have the highest vapor pressure. Now I see that highest is definitely highlighted here because it is printed in capital letters. Then I underline this or I highlight this so that I can then know that this, I must not by accident look for the lowest vapor pressure. So that's one way of working with this. Okay. If I look at the next question, here, which one of the following compounds has hydrogen bonds between the molecules? Now, nothing was highlighted here, but a key word is definitely hydrogen bonds. So now I take my highlighter or I take my pen and I underline those keywords, because that will be key when answering these questions. So that is what I mean with the fact when I say look out for underlined words or highlighted words, which is in capital letters, and underline those. Look for words that's emphasized, maybe being printed boldly, or sometimes it's just there. You look out for those keywords. And also when it comes down to where there's data given, like 10 grams, highlight those 10 grams so that you don't miss it. Sometimes you read fast over a question and you miss certain information. All right. When you look at multiple choices, sometimes one technique would be to look for answers that you know are obviously incorrect. You immediately see it is incorrect. And then you mark those with a cross or just scratch them out. Then you select the correct answer from the remaining ones. This is called elimination. Eh? So I'm looking for obviously incorrect ones, and now I focus on the remaining ones, and from there I select the correct answer. Okay. Then lastly, never leave multiple choice questions unanswered. If you do not know the answer, then guess. It's the one place where you can guess, but preferably guess after trying to eliminate some of the answers so that you have a bigger chance of getting it right. So that's question 1, and it deals with multiple choice questions and how to approach those questions. All right, going on to question 2. Question 2 is an organic chemistry question, and it will have different sections. I'm quickly going to go over all of them. Now, the first thing here is you really need to know with organic chemistry the functional groups that we did in class. And you need to be able to close your eyes and just write them down. So on page 3 in our books, you have received a nice summary of your functional groups and your homologous series that you need to know. So I can, by closing my eyes, I can name them: alkanes, alkenes, alkynes, haloalkanes, aldehydes, ketones, esters, alcohols, and carboxylic acids. Those are the 9 series that we discussed in class. And those are the ones that you need to know. And you need to know what to look out for. What functional group make an alkane a alkane? And there I will look for carbons with only single bonds between them. Alkenes, I'm going to look for a double bond somewhere between the carbons. Now, if I go to something like my alcohols, then I will look for a carbon with a hydroxyl, a OH group, bonded onto that carbon atom. Then I know it is alcohol. And for all 9 of them, I need to make sure that what functional group belongs to that homologous series. One last example, if I'm looking for, let's say, an aldehyde, then I will find a C with a double bond O attached to it, and it will be at the end of the chain, not in the middle of the chain, because then it is a ketone. But if it's at the end of the chain, we call it a formyl group, then I know this is an aldehyde, and the aldehyde, that's how I typically then describes it. So that is functional group, homologous series, and go and study them on page 3. So if you are there without your book, I hope you have a pen on hand and a piece of paper, and then you just write down page 3 so that you can go and revisit that later. Also, study your general formulas. You will find this in question 1. Your general formula, even if you can remember the general formula for a alkane, then it might be that it is possible for you to derive the general formula for an alkene. Because if I look at the alkene, they will always have 2 hydrogens less. So then the plus 2 falls away from my general formula for an alkane, which is CnH2n plus 2. And if 2 hydrogens fall away, then the general formula for an alkene then must be CnH2n. All right, so know them, and maybe you can even derive the general formula. But general formulas, very, very important that you know them. All right, so that is my first part of question 2. I know there's going to be questions on functional groups, homologous series. I need to know page 3 in my terms and definition book. It's a nice summary there, and go and study it and know as much as possible. Then question 2 will be a question where you will get your marks. The next thing that we find in question 2 is that you have to name some organic structure. So we are going to give you a structure, and then we are going to ask you to name that structure. So, and you will see in your books, there are many of them in your books where you will find a structure given, and definitely we're going to ask you to give the IUPAC name of that structure. Now, if you don't know your rules for naming structures, then you need to go to page 6. So there's the second page you need to dot down. You go to page 6 in your Terms and Definitions book, and you will find your rules for naming there. I just want to indicate some of the important rules for naming. First of all, we know that hyphens are used between a word and a number. So we're going to use a hyphen there. For example, 2-methylpentane. So there's a number and a word, and then we use a hyphen. And then there's no spaces on either side of the hyphen. It's linking the word with the number. Then where do we use commas? Commas we use between numbers. So if I have 2,3-dimethylpentane, then we will write 2,3. And now because I'm linking a number with a letter or a word, then there will be a hyphen, and then it is my name, for example, dimethylpentane. So commas between numbers, hyphens between numbers and words. All right. Then, of course, marks will be deducted if you omit a hyphen or a comma. That is always counting a mark. All right. And then we never use hyphens between words. And we have only two situations. Most of the names are one words, but there are exceptions when we do have two words. Okay. All IUPAC names are written as one word, except those of esters and carboxylic acids. Here I've got some examples for you. Propanoic acid is a carboxylic acid. That's why propanoic and the word acid will be two separate words. I said here that only esters and carboxylic acids is two words. So if you think about the ester like ethyl propanoate, then the ethyl is separate from propanoate, two words. But all others, if I think about methylpropane, one word because it's an alkane. If I think about chloromethane, it's one word because it is an alkane. Only esters and carboxylic acids are written as two words. All right. I hope you are keeping up and that I'm not going too fast. And because I've got so much that I actually want to share with you. So far we've indicated page 3 as a summary, important summary page, and also page 6. All right, the next one that I would like to now focus on is we are going to ask you in question 2 to draw a structure. Okay, so also there we have our rules for drawing of structures. And I can highlight the most basic ones for you. All right, all bonds must be shown. The question is, draw the structure, the organic structure. You must show all bonds. Okay, it's either a short vertical line or a short horizontal line. No parts of your structure should be condensed, like writing out CH3. Even the bonds between the C and the 3 hydrogen atoms must be shown as a short line, vertically or horizontally. All right. Bonds between oxygen and hydrogen, you must show those bonds as well. Don't write OH. You need to show the bonds between the O and the H, as well as the bond between the carbon and the O. Make sure nowhere do you use condensed structures. All right. All atoms must be shown also around the carbon, all of them. Marks will be deducted if you show only certain bonds. So make sure that you show all bonds. All right. Then as a final check, you must ensure that around a carbon atom, there will always be 4 bonds. Around any carbon, there will be 4 bonds. Around an oxygen atom, there will always be 2 bonds. And around a hydrogen atom and halogens like bromine or chlorine and so on, you will only find 1 bond. So that's an easy way of checking that you have not made a mistake somewhere. You will find 4 short vertical or horizontal lines around the carbon. You will find 2 around oxygen, and you will find 1 for halogens and hydrogens. All right. Then, so you're going to get a structure to draw that you can know and practice it. There's numerous questions where you need to draw it in old question papers in your book that we have supplied to you. All right. Then expect questions on isomers. Now, on page 9 in your books, there's a very nice summary on isomers. Isomers is always there in the question paper. We have structural isomers, and those isomers can be separated into 3 different kinds. We get chain isomers, we get positional isomers, we get functional isomers. All right? So that is our 3 different types of structural isomers that we get. Now, one tip I want to give you is that with functional isomers, it means same molecular formula, but different functional groups. And here you can dot this down. Your carboxylic acids and your esters, they nicely forms functional isomers. So then you need to, now you will know what to look out for. If I give you different compounds, you find your carboxylic acid, you find your ester, and you just check if they have the same molecular formula. Same number of carbons, same number of oxygens, same number of hydrogens, and then you can know that they will be functional isomers. With positional isomers, we will be in the same functional group, in the same homologous series, we will be there. Like, for example, alcohols. But the alcohol, the OH, will be on different carbons, so it will be on a different position. Same molecular formula still, different positions of the functional group. So propan 1-ol, propan 2-ol, that's good examples because you can see the OH, the hydroxyl, is just on different carbons. One on the one and the others on the second carbon of propan. Propan 1-ol, propan 2-ol, good examples of positional isomers. And then if we look at chain isomers, here you will look at different chain lengths, but still the same molecular formula. That applies to all of these functional isomers. So look on page 9, there's very nice examples, and then you go to your questions, and this marks you must get. This is achievable marks that you can get. Then also expect a question on primary, secondary, and tertiary compounds. And that you're going to find on page 4 and page 5 in your terms and definition books. And we focus here mainly on only 2. We are looking again here for alcohols, and then we can also look for our haloalkanes. All right. So alcohols and haloalkanes. So the key here is if I have a secondary alcohol, then the carbon on which we will find our hydroxyl group will be bonded to 2 other carbons. Then we call it a secondary alcohol. It's nicely explained on page 4 and 5. Secondary, tertiary, primary alcohols, secondary, tertiary, primary haloalkanes. Only those 2 possibilities. And there's always a mark of 2 that is achievable for this part. So please look at your summaries on those pages. Okay, so that is question 2, and you should have a clear picture now of what to expect there. You're going to have to name a structure, you're going to have to draw a structure, and then it's smaller things in between like secondary alcohols, tertiary alcohols, and also your isomers, your 3 different types of isomers. So I hope question 2, when you jump into that question, you do really well, and it will set you up to feel positive about the rest of the paper that's still to come. Looking at question 3, this question deals with intermolecular forces between these organic compounds, and we link the intermolecular forces to boiling points, melting points, and vapor pressure. Now, if you want to look at nice examples, you go to page 21. Just jot this down for question 3. Look for examples on page 21 in your book, and then you will be able to see exactly what we will be speaking about there. Now, if I look at the summary in our book on page 20, if you can open there, you can look at the summary. Then the following is very, very important, is that the strength of the intermolecular forces, that strength determines how high is the boiling point. So strong intermolecular forces relates to high boiling points, and weak intermolecular forces to low boiling points. The same goes for melting points. Strong forces, high melting points, but inversely, vapor pressure. Strong intermolecular forces, low vapor pressure. That one is inversely proportional. So keep that in mind. Now, if we look at our different homologous series, on page 20, you really need to go and study this. And that is that if we look at our alkanes, alkenes, and alkynes, they have London forces. Those three have London forces, no other intermolecular forces. Normally these forces are very weak, but we do know that these forces increase when we have a longer chain length. When we have a longer chain length, for example, let's say I am now comparing propane with pentane. You can see pentane 5 carbons, propane 3 carbons in the chain. So we have a longer chain with the pentane. Then that means that we have a larger surface area that is linked to butane. I said pentane. Pentane was my example there. So a longer chain, we have a larger surface area. Both my examples, propane and pentane, has got London forces between the molecules. But the London forces related to pentane will be stronger because of that longer chain and that larger surface area. Now, when we describe the difference in boiling point, melting point, and vapor pressure, we also need to look at energy. So we have to say something that like more energy is needed to overcome the intermolecular forces for pentane. And then we make our deduction for the 4th mark, where we will say that pentane will thus have a higher boiling point, or a higher melting point, or a lower vapor pressure. So there I've quickly discussed the ones where we are looking at a difference in chain length. Now, all 9 the series that we know, alkanes, alkenes, alkynes, aldehydes, ketones, esters, haloalkanes, alcohols, carboxylic acids, all of them has got London forces. So if I'm comparing 2 alcohols, then with different chain length, then I'm going to refer to the London forces. All right? So that is quite important. If I'm comparing chain length or branched, then I'm looking at the London forces. Now, if I go to my next group, which is the aldehydes, which is the ketones, which is the esters, and the haloalkanes, they go together, those 4. In addition to the London forces, we also find dipole forces. All right? Because they have permanent dipoles. So those 4, they also have a second type of intermolecular forces. So if I compare, let's say, an alkane with aldehyde, and more or less the same chain length, more or less the same molecular mass, then I will compare an alkane which only has London forces with the aldehyde which also have dipole-dipole forces, which is stronger. So that will give me indication then that the aldehyde will have a higher melting point, a higher boiling point, a lower vapor pressure than the alkane. I hope this is clear to you. And then we go to our last two. Our last two here is the alcohols and the carboxylic acids. Now with them we find a third intermolecular force, which we call the hydrogen bond, which is quite strong. And even if we compare an alcohol with a carboxylic acid, we know that the alcohol has one site for a hydrogen bond, carboxylic acids has two sites for a hydrogen bond. And that's why our carboxylic acids will have even stronger intermolecular forces than the alcohols because of those two sites. But you need to study that you know exactly each one of the 9. So if I say to you ester, you need to know there's London forces as well as dipole-dipole. If I say to you alkenes, you need to know we are only talking of London forces. If I say to you alcohols, then they have London forces, which normally goes about the chain length. They also have dipole-dipole, and they have that strong hydrogen bond that is also possible. Look for the things to study on page 20 in your terms and definitions summary guideline that we've supplied to each and every learner in the Free State. Right, now on page 21 you will find good examples and where they show you exactly the 4-step answers that we want when we answer this question. Boys and girls, I strongly believe you can do well in this question. If you know your intermolecular forces, you apply your steps to get your answer, then to answer the question on boiling point and melting point and vapor pressure, you can do well in this question. So remember, what is the 4 steps we are going to answer? Number 1, we are going to look for what is the intermolecular forces. We're going to name them. The second one, we're going to look at the difference in structure. Is there a difference in length of chain? Are there a difference in functional group? And we are going to look for that. Then we're going to state what is this effect. In other words, we will say the one has got a longer chain than the other one. Therefore, we know that the intermolecular forces is stronger. We're going to compare the intermolecular forces. And then lastly, remember to say something about the energy. More energy will be needed to overcome the stronger intermolecular forces. And then we make our deduction, which is that is why the boiling point is higher or the vapor pressure is lower. I hope this helps you with question 2. Go and look on page 20 and 21. I promise you, you will start to understand what is the knowledge part that you have to have here. Okay, so that is question 3. Going on to question 4. Question 4 is the question which deals with organic reactions, the reaction that take place. Now, I know learners in the past didn't do that well in this question. What I want to say here to you is that you only actually have 13 different reactions that you need to know. 13 different reactions. And when you break it down, that 13, then you will see that for the alkanes, you only need to know 3 reactions. There's only 3. It's an oxidation reaction, then it's a reaction with a halogen, and the third one is cracking, where we break that alkane structure into smaller compounds. We call it elimination. So there's only 3 for any alkane which is a reactant. Then if we go to our alkenes, there we have 4 different reactions that we need to know. But what is nice about them, all 4 of them will be addition, because with alkenes there's a double bond between the carbons. That double bond always breaks before anything else can happen, and then addition can take place where some of the reactions then can be added to that alkene compound. So there's only 4 addition reactions that you need to know there. And it's one with oxygen, no, I'm lying, it's one with hydrogen, it's one with a halogen, it's one with water, and it's one with hydrogen-halogen combination like HCl or HI. So that is the 4, but all of them addition. Then we go to the third group, which is our haloalkanes. And there we only have 3 reactions that we need to know there. The one is a reaction with water, the other one is with diluted sodium hydroxide, and the other one is with concentrated sodium hydroxide. Go and look for those. Then lastly, we have our alcohols. And you will see only 3 reactions there of the alcohols, of which the most important one, which is always in a question paper, is an alcohol with a carboxylic acid to give us what? To give us an ester. So there's 3 reactions there. When you add it up, you get to 13 reactions that you need to know. When you go and look on page 31, 32 in your terms and definitions book that we have supplied to you, then you will see there's a very nice visual summary of them. The 3 for the alkanes, the 4 for the alkenes, and so on. So when you look at those, you study what is the product that will form, you look at what will be the conditions of these 13 reactions. Do I need to supply heat? Do it need to take place where I add some sulfuric acid as a catalyst? Do I use a platinum catalyst? All the conditions is there, okay? And then know the type of reaction that you need to. Is it addition? Is it substitution? What type of reaction? And it's in those summaries. All right, that is question 4. Going on to question 5, we have a question on reaction rate. And your factors, you will find the summary on page 43. Factors like concentration, temperature, catalyst. Those are important. One, the state of division, as well as the type of reactants. Your calculations, examples of calculations, page 43. You are going to get something on the collision theory. Remember, the collision theory, guys, tells us 2 things. During collisions to form products, we need to have sufficient energy, higher than the activation energy. That's sufficient kinetic energy. And then secondly, during the reaction, the molecules or the particles need to have the correct orientation. Then also go and look on page 45, Boltzmann-Maxwell curves and how to explain them. The examples is there. That question will form page 43, 45 will form the reaction rate questions. This question is also nicely linked to practical skills, which you will find on page 43. And understand the different ways there to measure reaction rate. Understand variables, because this is now a practical question. For example, if I tell you I'm studying the effect of temperature on the reaction rate, that means that temperature is my one variable. It will be my independent variable. And I'm going to measure the reaction rate, so that will be my dependent variable. So all other variables like concentration and so forth, that I need to keep constant, and we will call it a controlled variable. So go and look on page 43. There you have a very nice summary for that. Moving on to page 6, chemical equilibrium. That is now where we have 2 reactions, a forward reaction and a reverse reaction taking place. And it will always be in a closed system. If any of these factors like concentration and temperature and catalyst, when any of those change, then we will see that there is a change in the equilibrium. There's no more going to be an equilibrium until a new equilibrium is established. And that is the principle of Le Chatelier. Now, when you look on page 63, the principle of Le Chatelier, the 5 steps that you need to explain in a descriptive question is on page 63 in that terms and definitions book of yours. And make sure you identify the disturbance. It will be one of the 5 factors that influence reaction rate, and thus, which will affect also your temperature, your equilibrium. And then we know Le Chatelier says that if I increase the temperature, then the system will react to try and decrease the temperature by favoring what? The endothermic reaction. So there I've got 3 marks already. Now I just see which one is endothermic, reverse reaction. I state which reaction will be favored, or the forward reaction. And then lastly, I say something about an increase of the number of moles of products or reactants. The 5 steps for that descriptive question on the Chatelier, it is there. Guys, and then you will get a KC calculation. We've done a table method there. Work through them so that you can get some marks there. It is a given that that question will be there. All right. Looking at acids and bases, very nice summary on page 79, 80 and 82 and 83, where they show you strong, weak acids, conjugate pairs, calculations, concentrated versus dilute, titrations, pH calculation, choice of indicators. Right, so then after that you're going to get 2 more questions. The one is galvanic cells. The other one is where we use table 4b. Your other one will be electrolytic cells. Now, what is the difference between these 2 questions? And the one with galvanic cells, chemical energy is converted into electrical energy, and there's a flow of electrons. In the second one, the electrolytic cells, there we supply energy from a source, electrical source, and then it's converted into chemical energy. And you only need to know 4 applications, only 4 applications. Look at page 104. If you look at page 104, then you will see the 4 applications. Page 104, 105 is there. I want to highlight just quickly. Concentrated sodium chloride. The sodium don't receive electrons. It's water that will be receiving electrons. And then when I compare that to the decomposition of copper chloride, there it's the copper and not the water that's reacting. So know that small little things but only those 4 on page 104 and 105 will be asked. Then another one is electroplating. Another one is purification. So I always say I'm electroplating something to make it look more beautiful. So here I tell them, remember the object is on the negative. And then when I go to purification, the thing I want to purify will be on the positive. And I just remember this sentence. It's very positive to purify something. So then I know the compound I want to purify must be on the positive electrode. And then for electroplating, it's just the opposite. It must be on the negative electrode. So, ladies and gentlemen, boys and girls, everyone there, I've given you so many tips. I wish I had more time to spend with you. You know, if you're a science teacher, you never get enough time to point out things. And I really hope that you have gained something from this session. If you only dotted down the page numbers, that is so important to look at those content summaries before you start to dig into the questions. I strongly believe there's so many marks that you would pick up. A lot of knowledge, a lot of studying, work hard, and I really hope you have a very good question paper when you write paper 2 on Monday. Right, there's a small competition to end off with. MTN is always sponsoring us some prizes. Today it's a cap and a t-shirt, a nice t-shirt. If you want to send in your answer, you need to go to the following place. On Facebook, you go to the Free State Department of Education, and then you're going to post your answer there, and hopefully your name will come up with that MTN cap and t-shirt. Here is my question for today. I kind of alluded to this during my presentation. The goal of an experiment is to investigate, listen carefully, the influence of concentration on the rate of the reaction. So it's concentration on the rate of reaction. That's the goal of my experiment. I want to investigate concentration on the rate of reaction. The question is, identify the dependent variable. So just answer that on our Facebook page of the Free State Department of Education. You might be the lucky one to win yourself an MTN cap and t-shirt. So with that from me, Mr. Kleinhans, I hope you have a good weekend studying hard, and may your hard work be rewarded on Monday. Thank you so much and good luck.